Hello, in this video, let's study what is momentum and what is impulse. And then we have an impulse momentum theorem, very similar to work energy theorem we have. Momentum is defined as m times v, the velocity of the particle. So v is a vector, p is m times v, so it's also a vector, and the p is in the same direction as velocity. Momentum is in the same direction as velocity, vector. And the more rigorous definition of Newton's second law should be net force equals dp dt. And the F equals ma we have. F equals ma is a special case of this equation when m is a constant. This is definition of momentum. Impulse is, if we do an integration of force over time, is impulse. Now, of course, if it's a constant force, then impulse is simply F times delta t. F times t give us impulse. In graphic, if we have F in the y-axis, t in the x-axis, plot F as a function of t. F integration of t give you impulse, then the area under this F curve give you impulse. So you can have a force like this, it give you an impulse. Now you can have a rectangular force, rectangular shape, which is essentially a constant force, times t give you the same impulse. Now if F, this constant force times delta t equals this very complicated impulse, then we call this force average force for this impulse. So you can have a very large force acting for a very short time. You can have a small force acting for a long time. As long as the area under the curve are the same, so you can apply the same impulse on the system. And now we have the impulse momentum theorem. Impulse momentum can be very easily derived from Newton's second law, F equals ma. Impulse momentum says the change of momentum of the system equals to the impulse applied to the system. So let's do one example to understand impulse momentum theory. So we have a 0.4 kilogram ball with initial velocity 30 meters per second move to the left, bouncing into a wall, and the rebound. The final velocity is 20 meters per second, pointing to the right positive x direction. We want to find out the impulse. And then from the impulse, if we know the contact time, we find out the average force. How do we find the impulse? Now, this problem didn't give us force, didn't give us time, so we cannot use F times delta t to calculate the impulse. But this problem indeed gave us the initial velocity, final velocity, and the mass. So I can calculate what's the initial momentum, what's the final momentum. So we can calculate the change of momentum, right? And if you calculate what's the change of momentum, the impulse momentum tells you this is impulse. Okay, so we can find out what is impulse. The initial momentum of the object, so let's calculate. 0.4 kilogram m times v initial velocity And the initial momentum is negative because P1 is pointing to the negative direction. Initial momentum 0.4 times negative 30, so it is negative 12. And the unit is kilogram meter per second. And then we need to find out what's the final momentum, right? We know the final velocity is 20 meter per second, so it's m times v, give you a final momentum, which is 0.4 times 20, give you 8 kilogram meter per second. So what is the change of a momentum? So it's not 12 subtract 8, or it's not 8 subtract 12. You see, your final momentum is 8. So its final momentum subtract the initial momentum, and the initial momentum is negative 12. So it's 8 subtract negative 12 gives me 20 kilogram meter per second. And the impulse momentum tells me impulse just equals to the change of momentum. The impulse equals 20 kilogram meter per second as well. Now I do know the time of contact is 0.01 second. So F average times delta t give you impulse. And I do know F delta t, I do know impulse, so I can calculate average force is impulse over delta t, 20.01 Newton, give me a 2000 Newton force. So the change of momentum is 20 kilogram meter per second. But because of the time of contact of the ball and the wall is small, is 0.01 second, so the force action is not, the average force action is not on the ball. So in the next video, we're going to talk about momentum conservation and kinetic. Thank you for watching. See you next time.